Heat management system in a vehicle when parked. Abstract. This study aims to formulate competencies in automobile air conditioning system, using tech for its effectiveness, efficiency, environment friendliness, comfort, and convenience. The heating up of the vehicle cabin on being parked under direct sunlight due to greenhouse effect causes immense discomfort to the passengers when they enter the cabin. The proposed design analyzes the heating methodology of a passenger car parked under sunlight by experimental methods taking into consideration the solar irradiance, temperature at various data points in the cabin, on the basis of which, design an air conditioning system by the usage of thermo-electric device and optimizing it to perform more efficiently with the least power consumption suited for imminent technologies in automotive industry. Keywords: TEM, thermo-electric module, tech, thermo-electric cooling, cooling chamber, HVAC, heating, ventilation, and air conditioning, and fins. 1. Introduction. The overall idea of the system is to use the roof of a car equipped with solar cells to collect the energy of sunlight in the hot summer. It is stored in the car battery to drive the automobile blower and the tech. The blower to ventilate the cabin, and the tech cools the blower ducts air. The air conditioning condensate collected during the driving process is used to cool the hot end of the tech to improve the cooling effect. The tech is a refrigerating device based on the Peltier effect, which has the advantages of small volume and no noise, but the cooling effect is limited because the tech's refrigeration power is affected by the hot end temperature. The higher the hot end temperature, the lower the cooling power when the input power is constant. Here we are using 4 modules of Peltier device in which we are using 2 heat sinks, one for cold side and other is hot end side. The design should achieve the primary goal of maintaining ambient temperature in the cabin and also maintain minimum space requirements. The secondary goal is to maintain the interior parts and to protect the goods and products kept at the cabin from aging and damage respectively. Other than the damaging or aging taking place, the other major problem is that the dangerous gases like benzene, volatile organic chemicals, etc., being released, which causes increase in the risk of heart diseases, asthma, emphysema, causes skin cancer, lung cancer, and damages to nervous system. In this study we focus on developing a model that works on non-renewable source of energy to maintain ambient atmospheric conditions inside the cabin and by minimal cost. Where the conventional HVAC system consumes about 8 H.P with a unit capacity of 3 tons of engine power, the use of Peltier embedded system can overcome this engine power loss, making it more efficient. 2. Methodology. The main objective of this project is to design a cooling system installed on a conventional blower of car AC. The idea of cooling is based on Peltier effect, as when a DC current flows through TE modules it generates a heat transfer and temperature difference across the ceramic substrates, causing one side of the module to be cold and the other side to be hot. The purpose of the project is to make use of the cold side to cool the ambient air to a lower temperature, so that it can be used as a personal cooler. Testing and measurements are also performed on car, Hyundai i20. A simple temperature controller to interface with the cooling system has also been incorporated. Based on an analysis of sizing and design of the tech air cooling for car, it can be deduced that the cooling system is indeed feasible. Readings taken during testing also testify to the fact that the TE cooling for car can lower the ambient temperature by 7 degrees Celsius. 3. Experimental setup and survey. The temperature range inside the cabin due to radiations incident on glass and heating up of cabin space are recorded for over a period of 5 months from January to May 2020, where temperature survey is conducted.